All right, let's talk about graphical displays. So the ones we're going to talk about today are bar charts, pie charts, and histograms. We've already had some experience with some of these, but we'll get into a little more depth here. So let's start with bar charts. Bar charts summarize the frequency distribution of the categorical variable, which we know is usually saved as a factor. So here's the pseudocode. So you're going to use the function barplot, but barplot once, if you read the help file, a numeric vector or a table will work. So table is the easiest way to summarize the factor that you might have. So let's just work with the class data. I'll load my workspace with the class data. And just a reminder, here's all of the variables I have. I have a couple of different factors: Pinterest, Snapchat, gender, class. So let's just attach the class data here. It's already attached. So here's what we're going to do first. We'll make a gender table. So if you look at gender, if you see what this object is, simple table, right? Is the values of the factor and how often it takes on those values. So gender is female and male, 23 females, 12 males. Let's make a bar plot. So here's just the basic bar plot of the table, and it plots on the y-axis the counts, and on the x-axis it goes ahead and assigns the labels F and M. So you can read help of bar plot for all of the options, and you'll get some practice on this in your homework. So a lot of useful options. You'll want to read through all of those. All right, so let's do open a new plotting window. So I can show you a little bit fancier bar plot, again using the options that you're probably already a little bit familiar with from plot. So I'm going to run bar plot of my gender table, except for now I'm going to have names here. I'm going to make a horizontal bar plot, so the bar plots will be horizontal instead of vertical, or the bars will, and I'm going to add colors 2 and 3, and a Y label and an X label. So a little bit more options. And you'll see that's what happened here. I changed the arguments, the names argument to female and male instead of just F and M. Horizontal, and count is now on the x-axis. I'll throw on a title, bar plot of gender. Okay, so let's see how we might do a little bit more advanced bar plot. The first thing that we want to think about is, what if we have a J by K table of categorical variables? So we have two variables. So we'll see an example in a moment. The main idea is going to be to transpose and aggregate the data. So transposing, we'll just flip the rows and columns, and aggregating will allow us to do things like compute the mean across gender, for example, very easily. So here's the pseudocode. I would take table and have a list of factors. So I could have 3 or 4 or 5 factors, but the plots get a little bit more difficult. Typically we would only make a bar plot of 2 at once. And then you run bar plot of your table that you created. You can also aggregate data using aggregate. So this says, the pseudocode says, take my continuous variable in your data set. The tilde, we've seen this already in the linear model function, so continuous variable by factor. And then you have to tell it the name of your data set is my.data, and you have to tell it function like mean, standard deviation, variance, etc. And then that will allow you to make a bar plot where the values outputted, so for example the means or the standard deviations could be the length of the bars. So a quick example is the easiest way to learn. So here, first of all, here I have gender versus Pinterest. So I've created a table of gender and Pinterest. So now I can see that here are the values of Pinterest. People either did not, that's an N, or did have a Pinterest account. And then here I have the values of the factor gender are female and male. So for example, this tells me that there were 10 females that did not have a Pinterest account. There are 10 males that did not have a Pinterest account. The number 13 is the number of females that had a Pinterest account, and the number 2 is the number of males that had a Pinterest account. A couple of ways to plot this now. Let me just make this plot. So I'm putting a title, Pinterest versus gender. I'm putting an X label, gender, or X label is Pinterest, excuse me. And on the Y label, or on the Y axis, I have total number of Pinterests, and I have those broken down by male and female. So here you notice I have a legend, so bar plot allows you to work directly with legend as an option. The legend is going to be the row names of gender versus Pinterest. So you can see what that is. Just returns an F and an M for female and male. So if you're going to do this stacked bar plot like this, which is the default bar plot when you have two factors, or a 2x2 table, or a 2x3 table, 3x3 table, etc., you need to indicate which box belongs to male and which box belongs to female, right? So that's why legend works pretty well. What did this last argument do? I'm going to create the same plot, but I'm going to add this argument besides equals true. And what's that going to do? It's going to stack these beside each other instead of on top of each other. Okay. So maybe a little bit easier to read. I prefer side by side instead of stacked bar plots. So now here I have Pinterest. Here are the people that did not use Pinterest. We have 10 females and we have 10 males. Among the people that did have a Pinterest account, we have 13 or so females and then very few males. So this is a little bit easier to read. If I wanted to switch, so suppose I want my legend to include Pinterest users, and on my x-axis I wanted gender. All I need to do is transpose gender versus Pinterest table. So if you type gen v pin, here I have gender and Pinterest. What's this transpose going to do? It's just going to flip it. Put gender here, Pinterest here. That's the easiest way to switch what I have on my x-axis and what I have on my legend. So now we'll do this. So if you wanted to view gender as the factor and Pinterest as the response, which would be maybe more appropriate, you would put gender on the x-axis. And on the y-axis, you plot your response variable, which is whether or not they have a Pinterest account. We can also use the aggregate function, as we mentioned. So if you should read the help file for aggregate, I'll let you do that on your own. But here I have introvert, that's my response by Pinterest, so just like the linear model. So tilde is important. These variables have to be in your data frame, so data equals class data. Indeed, introvert and Pinterest are in the data frame, and function is the function that you want to apply. So what this did is simple enough. It went and got all of the people that did not have a Pinterest account and computed their mean introversion level. People that did have a Pinterest account and computed their mean introversion level. And I might want to plot these numbers as bars. And I can do that with the bar plot still. Okay, so I can have counts. The counts can come from a table, or they can actually just represent a mean or any other number. So again, the names, Y label, colors, main, we've seen these options before. You don't have to just use, so here we have the function mean, which just returns one value. We also have this function we've seen a couple times, summary, which goes and gets the 5-number summary and the mean. So if I do, I can use the aggregate function on to compute the summaries of introversion by Pinterest, and it will work. do is, here I have my non-Pinterest users, and then I have introvert, which is the name of my variable, and remember summary returns a minimum, first quartile, median, mean, third quartile, and max. So it doesn't have to just be one number that's returned by the function, it could be a whole summary. Okay, let's look at pie charts. So here are the notes. Pie chart summarizes the frequency distribution of a categorical variable. It can input a table or a numeric vector, just like bar plot. There is a bit more restrictions. You can't have negative values, for example, because pi, what it wants, I'm going to create a table of a factor, and when I create the pie chart using the pi function, it's going to not understand how to plot negative values. So let's read the help file for pi, just as you always should. And it gives you a vector of non-negative numerical quantities. These can come from a table by creating a table, or you can just type those in. And we'll see a few examples. And then here's all of the options you should read more on your own. Things like clockwise, where do we start? If we have orders, do we go clockwise or counterclockwise, etc. All the different things that you can do to a pie chart. So here's a simple one. I'm going to, here are my slices, so these are the values. So these could come from a table, from a factor, or I can just input a numeric vector. And I'm going to input these labels: US, UK, Australia, Germany, France. So these represent some values, I think, having something to do with crime rates in the different countries. And now I'll make pi. The main input is the slices. So these don't have to represent degrees. Like it doesn't have to represent 10 degrees. It will automatically scale. It'll take the total and compute the percentages as necessary. So the main argument are slices for the values. So 10, 12, 14, 16, 8. And then the labels, I'm going to want to put labels and a title, simple pie chart. Okay, so it'll automatically put the labels on the outside of the pies and draw these lines. Let's make a little bit fancier pie chart. So I want to compute percentages, so I want to label UK and I want to assign a percentage to it. So here's what labels2 looks like. Remember, the paste function allows us to paste variables and texts and so on. So I'm going to have labels, which is the US, UK, Australia, Germany, and France. I'm going to put a space in there. And then I'm going to attach their associated percentages, and then the percent character, and use sep equals no separation, so I don't have a bunch of unwanted spaces. So labels2 looks like this. I just created this US 20%, okay, using this paste function. And I want to use these as labels instead of just US, UK, France, etc. And I'm going to add a little bit. What did this color? Rainbow. I'm just using rainbow colors. So if you want to see what that does, type that guy in. And it knows how to, R knows how to work with, R knows how to interpret these things. All right, let's talk about a histogram. So what does a histogram do? It displays the distribution of a single continuous variable. So we're switching from categorical variables to continuous variables, so no longer factors. And we're going to use this thing called density to draw a curve over the top of a histogram. That is a kernel density estimate of the PDF. That's a little bit complex. You can read the help file or take a non-parametric statistics course to learn more about what exactly how that's being drawn. exactly what that's doing, but you can just think of it as a smoothing of the histogram. So here's the pseudocode. I'm just going to run histogram, my variable. We've seen this already a little bit, so I'll go through this fairly quickly. So here is the Old Faithful data. So this is, we've already attached it, so let's detach. And I'm going to construct a histogram of waiting times. So waiting times, these are the times between eruptions. So the Old Faithful geyser is called Old Faithful because you can predict fairly accurately how long until the next eruption. And to see why, you can look at this histogram. Waitings on the x-axis. So on the y-axis are the frequencies. So for example, for this data set, you'll notice that the waiting time, or the time between eruptions, was between 40 and 45, about 3 times. Between 45 and 50, about 22 times or so. Let's make a little nicer histogram. I'll show you some options. We've seen this probability equals true option already. So this will scale the y-axis so that the sum of the bins is 1. So this represents a probability. The y-axis represents probabilities. I'm going to force the number of breaks and the color, and I'm going to change the X label and add a title. So you'll notice the number of breaks is 25. I now have 25 bins, so it's a little rougher. The y-axis is now rescaled. My histogram is red. And you can read more about this jitter function, but what that's going to do is essentially draw what we know as, well, it's going to draw a line on the x-axis every time we see a point. So you'll see when there's several lines overlapping, that means so when the lines are thicker, there were more values in that box. In the rug, told it to put it underneath on the x-axis. Okay. So if you want to see what those do, first run jitter of waiting. That's all it did. Then you can read the help file for rug. Now I'm going to add a density plot. Here's this nice smooth density. We've added some density plots already, but we've only used a normal density, so this is a little bit more advanced. And remember, the lines is just going to add lines to the existing plot. Okay.